And this space is for you. All right, all right. So now we're back, and this is the last section, the last piece of Unit 2, standard deviation. And again, right, we're starting the modules, and we look at the PowerPoint for standard deviation. Then, as I said, this is where the math really comes in. Okay. Once again, order of operations, just simple stuff. Nothing. The most complicated thing here is square root. Your calculator does that. So, standard deviations. I'm sorry about this. Anyway, standard deviation. So the standard deviation, the symbols are this, and I will update. I didn't put all of these in the symbol page from the intro module, but I will. Standard deviation, and this omega sign is another form of that's for standard deviation. And basically for us, I'm going to use this when we're talking about a population, and you're going to understand what that means in a second, right? And so omega, this is the standard deviation of the population. This symbol is the sum of, meaning we're going to sum something, and we're going to add them all up. These are all your data points or scores. X bar is your mean from all those scores, and we talked about that already, right? And N is your number of subjects. So your standard deviation for a population, this is, I'm going to keep emphasizing population at the moment, right, is the square root of the sum of the score minus the mean squared, right? So, and over, divided by the number of subjects. Okay. I'm going to walk you through one, I believe right here. Oh, maybe not. So now we're going to talk about the standard deviation, and I just use the S here for a sample. So, a population is like, if I wanted to talk about the population of students from Delta College, that would include every student, whether it would take in one class, 5 classes, Mountain House, online, main campus, no matter what the situation of some of the high schools kids that are registered in Delta, right? That would include every student who's registered at Delta. If I wanted to do some research to try to reach out to them, it's not feasible to reach everybody, every student reliably and get some viable information. So what I would do is take a sample of students, and later on in the class, we'll talk about sampling and all of that. But right, basically what I want you to know is normally I can't reach out and reach every person in the United States, a population, right, 300 plus million. So researchers who are doing surveys and all that, they take a sample of that. Take like literally 1,500, 2,000 people, and the people that really do research, and get viable data from 2,000 people that applies to the 300 million total population. At any rate, so I just want you to know, we normally work with samples. We do not work with populations. So here it is again. It's the same formula except for this piece right here, which is now we divide by n minus 1 rather than n. Okay? And here's our example. And this is for sample. I'm not going to bother with one for the population. You should be able to converse one from the other. So for our sample, n is 6. These are our 6 scores, right? And this is our mean. This is what we want to know, right? Because we have x, we have the mean, right, which is just our scores added 10 plus 11 plus 11 plus 13 plus 15 plus 19 divided by the number of scores, or 78 over 6 is 13. So we have our mean, we have our n, and we have our different scores. And this is how it works. So here's my score. So for x, the sum of x minus x bar, or mean, and squared. Right? This is how we do it. The score is 10. I have 10 minus 13 equals negative 3. When I square that, I get 9. Okay? 11. 11 minus 13 is negative 2. When I square that, I get 4. 11 again, I get 4. When I had 13, I have 13 minus 13, 0. Square it, it's still 0. 14 minus 13 is 1. Squared it. 19 minus 13 is 6. And when I square that, I get this. And then I sum this column, right, to 54. So now this piece right here is equal to 54. Right? This piece right here is equal to 54. And we know what n is, right? And so we do that. 6 minus, right? So now we have the square root, and please don't drop the square root sign. This seems to be what happens to most people. Somewhere during the process, they just decide they don't need the square root sign. That's just not true. Okay? It's just going to be the last thing we do. So here we go. We got the 54 divided by 5. I don't know why I put that in there. I guess let me make a note of it quick. Sorry, I thought I did remove that. But it doesn't matter, right? So s is still equal to the square root of 10.80, which is 54 divided by 5, and that square root is equal to 3.29. So in this case, our standard deviation is equal to 3.29. You're gonna hear, we're gonna why that is important. But from now on, this is our building block. Like, this is going to be a focus of a lot of our stuff. We're moving forward. So please, if anything here is like unclear, reach out to me. Okay? So remember I said we were going to go back to those that diagram, right, where I said one standard deviation. So when I went here, right, I said one standard deviation is 3.29. So whatever this, if this was 0, then this 1 is 3.29. The slide here. This is 2 times 3.29, and this is 3 times 3.29. And here, this is negative 3.29. 2 times negative 3.29, and 3 times negative. Right, so right here, if I do this, this is actually becomes negative 6.58. And check my math, but I'm pretty good. All right. But what we really want to bring what I want to bring your attention here is now we have rules. There's a lot of rules about the bell curve and standard deviation, and here is what it says. The first one is 68% of scores fall within one standard deviation of the mean. Now, one standard deviation of the mean includes both sides, right? One here and one here. So even though we're only talking about it's one standard deviation distant from the mean. Right? Not just one, but one distant on either side from the mean, median, and mode. So in this section, the 68% of the people are going to score in here. All of this is based on a theory that we're going to talk about later, which you don't really need to worry about right now, right? But this is what I said. This is all about theoretical work and how this works, right? What we're saying is 68% of the scores fall right here. Rule one. Rule two, 95% of all the people are going to score right here within 2 standard deviations from the mean. So when I say within 2, I'm including the negative side and the positive side, right? Again, so we're talking about this whole area right here. I should figure out how to shade what I'm talking about. Anyway, we're talking about this, right? From -2 standard deviations to +2. This whole area, 95% of the people are scored will be in that area. And then 99.7% of all scores will be within 3 standard deviations of the mean. And you can see this little tiny space over here. That's that 0.3%. That will include some outliers, right? And for you guys, sometimes that's that person that blows it. These are the people that blow your curve. Right? If one of your professors marks on a curve, which I don't. All right. So those are the 3 rules you need to focus on. And here comes some more. Right. So I did the 68% rule, the 95% rule. This is the precise 95%, which actually says it says definitely, precisely 95% of the cases are within 1.96 standard deviations of the mean. And so, right, so 1.96 instead of like here where we said not 2 standard deviations, we're talking 1.96, which is really like right next to it, right? Just a little shade. But that's where we're saying absolutely 95% scores fall within that 1.96. Right? And so here we said 99.7 fall within 3. What we're going to really say, the more precise rule is 99% rule, or 99% cases fall within 2.58 standard deviations of the mean. Should move to. Sorry. How many times I go through it, I just find mistakes later. No, it's not. Oh, I think. It's because I shrank it. Sorry. Anyway, 99%, right? Within 2.58. So if you go back to the picture, right, instead of we're talking the 3 right here at the 99.7, we're talking 2.58, which is just a hair over 2.5. And so what we're really saying is here and here, and between that space is 99% of the case. And we're going to work with this, so, it's, right? So, why is this important? So, I'm going to tell you that we're going to be figuring out how this works. Okay, so here's an example of why the rules, what we're going to be doing with the rules. So we're going to do the 68% of this rule. Now I want to know what 68% of the scores, what's that value? So I need to know the standard deviation, I need to know the mean, and I need to know 1 times the standard deviation, basically. So it doesn't, right? Because in this 68% rule, we're talking about 1 standard deviation. 68% of the scores lie within 1 standard. So if I go back here, right, this is my curve, here's my mean. 1 standard deviation here, like let's just say the mean is 50. Did I say something else? The mean is 44. I'm sorry. So let's say right here the mean is 44. 1 standard deviation is, right, standard deviation is 4. So 1 standard deviation over here, this score is 44 plus 4, right? the equivalent of 1 standard deviation. So this right here, this score is 48. I add. So what I can tell you is 68% of the cases in this example fall between 40 and 48. And the way I got that was by, here's my 44. My standard deviation is 4. When I go to the negative side, I subtract, right, that 4. So 44 minus 4 is 40. So right here, the score is 40. I went over this already by adding, and right here, the score is 48. So from here to here, all the scores from 40 to 48 are right here. And 68% of the subjects scored between 40 and 48. That made sense to you, okay? Now let's talk more about we'll get into the precise rules a little bit, just so you can do it, right? Here, whatever I want, the 95% rule, I just do 2, right? So it's 44. If I want to know what what the score is at 2 standard deviations, are 44 plus 4 is 52, right? 48, 52. Same thing here. I subtracted 4 to 40 and I subtract another 4 to 36. So if you look at this and you look at the rule, 95% of the cases fall between this 2 standard deviations, and that score is 30. And those people, 95% of the people scored between 36 and 52. So let's go back to this example. So now I have a standard deviation of 4, and I have a median of 44 still. But now, right, I said at the precise rule, they're within 1.96 standard deviations of the mean. So now instead of multiplying just by 1, I have to multiply by 1.96, right? For the general rule, I would just multiply by 2 standard deviations. But for the precise rule, I'm going to be multiplying by what I said. All standard, the precise rule says 1.96 standard deviations of the. So when I multiply 4 by 1.96, I get 7.84. So now when we go back to the drawing, right, like I said, 1.96 is just a hair below 2. Right here, let's say, so that would be at 44 in the mean, right? So I'll start on the positive side. 1.96 is 44 plus 7.84. Which is 51.84. So right here, just shy of the 2 complete standard deviations at 1.96 standard deviations, that score is 51.84. Right here. I know that right here at 1.96 standard deviations from the mean, I have 51.84. The same thing on the other side, like we did previously, and subtract. So right here, almost at 2, I would subtract 44 minus 7.84, and I get 36.16, right? So just right here, not quite 2, but 1.96, I know that in that area, 95% of the people, precisely 95% of the people scored between 36.16 and 51, 36.16 and 50. All right, so that will become important to you. You're going to get questions about figuring that out on the exam. Okay. And that's basically our standard deviation at this point and what we're going to do with it. And like I said, we're going to be working with the standard deviation from now on. This is the biggest building block, maybe it's probably the biggest building block that we have from here on out. So please, any questions, any issues, come reach out to me and we will work through it. Okay? Like I said, there's nothing scientific, there's nothing big deal here, right? All you're doing is you're solving a problem. That's it. Okay? You're just doing math, right? Division, multiplication, the same thing I keep saying, right? All we did here was addition and subtraction, like nothing to it. Okay? Please reach out to me if you have any issues. Otherwise, we're going to be moving right into Unit 3 because, this is the shortened class and things move quickly. All right.